on to 3.7, part 2. It is. Okay, 3.7, part 2. Yesterday we solved absolute value equations. Today we're going to solve absolute value inequalities. No, we had equal sign yesterday. Today we get to have the greater than and less than signs. Alright, so first thing I want to do is go through the steps, right? They're not hard steps. Most of them are the same steps you've seen before. I'm only going to add one itty-bitty little new one. And that's it. Okay, so first, we need to get the absolute value by itself. Step 2. Once the absolute value is by itself, you're going to write two separate inequalities. Anytime you have an absolute value, you have to have two of them. Yes. The first one, all you're going to do is drop the absolute value signs and rewrite it. The second one, this is all part of 2 because it's what we're doing, right? The second equation, you drop the absolute value, flip the inequality, and make it negative. So yesterday we just wrote an equal sign to a negative number. Today we've got to flip the sign. That's the only new part. That's it. Okay, step 3. Solve both inequalities. Step 4. Graph. Step 5. If we graph, we always do interval notation. No, they're not. No, they're not. All right. So these steps, again, the only thing we've added today from yesterday is that because it's got an inequality sign, when we write the two of them, we're going to flip the sign and make it negative. It's the only new thing. Okay? So here's where I want to go from here. If we are having an inequality sign, there are two things that are going to happen today. If it's an absolute value, that means there's 2. And if it's an inequality sign, that means it's a compound inequality we're going to have. So we're either going to have an and or an or. Exactly. All right. So if our absolute value is less than or equal to a number, this is going to be an and problem. And if it's an and problem, that means your graph, when you graph it, is going to be sandwiched in the middle, right? It also means that you're going to have one interval notation. If the absolute value, when you get it by itself, is greater than or equal to a number, that is going to be an or problem, which means your solutions are going to go in opposite directions, right? You're going to have two pieces in the interval notation. Everything today is all packed together. The only new thing we're adding is flip the sign. That's it. All right, here we go with example number 1. We're going to start off super easy. Let's say I have the absolute value of 3x is less than or equal to 15. So first thing is that absolute value by itself? Okay, so that means we're going to drop the absolute value signs, rewrite it. 3x is less than or equal to 15. The second one is 3x greater than or equal to negative 15. Now we saw both of them. This one, when I divide both sides by 3, we get x is less than or equal to 5. This one, when we divide both sides by 3, we get x is greater than or equal to negative 5. Now, what do you notice about the two numbers? They're backward, aren't they? Okay? So just remember when you go to graph them, that on the graph, this one's going to be on this side. And, of course, it's less than, so it goes this way. And this one's actually going to be on this side. And it's greater than, so it's going to go that way. So this is an and problem. It's sandwiched in the middle. And we know that because look at what sign we started with. It was a less than, so it's an and sign. Our interval notation is simply a bracket, negative 5 to 5 with a bracket. That's it. Okay. So let's on the number line, exactly. What's going to happen, though, is a lot of times when we set two of them up, they're actually going to be in reverse order. So we got to make sure we put this one over here on the number line and this one over here on the number line. Okay? All right, let's do another one. Example number 2. All right, let's say I have the absolute value of n plus 3 is greater than 7. So this time it's greater than, which means when we're done, what kind of problem are we going to have? We're going to have an OR problem. Let's see if that's what happens. So the first thing I can do is my absolute value by itself. All right, so I have n plus 3 is greater than 7. I just rewrote it. Or n plus 3, flip the sign and make it negative. Now we solve them both. Subtract 3 from both sides. We have n is greater than 4. Over here, subtract 3 from both sides. And n is less than negative 10. All right, so again, on my number line, here's my number line. 4 is over here. It's an open dot, and it goes to the right. Negative 10 is over here. It's an open dot, and it goes to the left. All right, so here's one thing I wanted to point out. After checking your worksheets from yesterday, some of us wrote these two intervals in reverse order. They've got to go in numerical order, which means it has to start at negative infinity, go to negative 10 with a parenthesis, a u, parenthesis 4 to infinity. It does not make any sense if the first interval we have is 4 to infinity and the second interval we have is negative infinity to negative 10. That doesn't make any sense at all, right? It's got to go from negative infinity to positive infinity. It's got to be in that order. All right? Yes? Yeah. So think of it this way. Because we're making the right-hand side a negative, you're technically got to flip the sign. Do you know what I mean? And that's the only time you do it. Those are, well, the 2 times you do it. It's if you're dividing by a negative, or in this case, because we've got to set up 2 inequalities, the second one, you got to flip the sign when you make it negative. Okay? That's a really good question and a good thing to point out. Any other questions before we keep going? So it's making perfect sense so far, right? All right, here we go. Example number 3. All right, let's say I have 2 absolute value 3x minus 1 is less than 8. All right, we want to divide by 2 to get our absolute value by itself first. So we have the absolute value of 3x minus 1 is less than 4. Now a less than sign means this is going to be an and problem, okay? Well, let's see what happens. First one, we just drop those absolute values and rewrite it. 3x minus 1 is less than 4. The second one, we have 3x minus 1. Flip the sign and make it a negative 4. All right, over here I'm going to add 1 to both sides. So I have 3x is less than 5. Dividing both sides by 3, x is less than 5/3. Let's go over here. We're going to add 1 to both sides. So we get 3x is greater than negative 3. Dividing both sides by 3, x is greater than negative 1. All right, so on my number line, I have 5/3. I have an open dot, and the arrow points to the left. It is less than, so it goes this way. X is greater than negative 1. Jesse, where's negative 1 on my number line? Yeah, it's way over here, isn't it? Again, that's an open dot, and it's going to go to the right. So it is an and problem. Interval notation. The open dot is a parenthesis. Negative 1 to 5/3 with a parenthesis. Again, questions, anybody? No? Okay. Sample number 4. All right. Let's go with, because I know you guys can handle it, we're going to step it up a little. Let's say I have negative 9, the absolute value. Negative 4 plus 3x is less than or equal to negative 72. All right, so what do I have to do? Divide by a negative 9. And just like the one in the warm-up, what do you notice, Ian? Flip the sign. So I have negative 4 plus 3x, because I'm dividing by a negative. This becomes greater than or equal to 8. Now, is the absolute value by itself? Yes, it is. So I have negative 4 plus 3x is greater than or equal to 8. The second one, yes, Emma. Not necessarily. When it comes out of the absolute value, like when we have a value of what's in there, when that comes out, it's always positive. But whatever's written inside doesn't have to be. Okay? Yeah, you're welcome. The second one we have that negative 4 plus 3x. What do we do now? Flip the sign and make it negative 8. All right, let's go ahead and solve the first one. We're going to add 4 to both sides. So we get 3x is greater than or equal to 12. I don't like what that looks like. There we go. And then dividing both sides by 3, x is greater than or equal to 4. On this one, we're going to add 4 to both sides. 3x is less than or equal to negative 4. Dividing both sides by 3, x is less than or equal to negative 4/3. All right, so now we got to graph this. 4, solid dot. Which way does it go, Corbin? Goes to the right, okay. Again, that arrow is the same as my inequality sign. Negative 4/3, Corbin, where does that go? On the left side. All right, open or close dot. Closed. And this goes to the left. Again, same inequality sign. So interval notation follows this graph exactly. The arrow is our negative infinity. The closed dot is at negative 4/3, so I have a bracket. a U in the middle, excuse me, a bracket, 4, and again, that arrow means infinity. Yes. Well, there's always arrows. There's always. You're the one drawing it. You got to draw the arrows, right? Yeah? Except for me, it's easier to do the graph first, but for some people, it's easier to do the interval notation. Excuse me. All right. So next one. Here is example number, what am I on, 5? Not necessarily, only if they're closed dots, Jordan. Right. All right, let's try a harder one. Okay, let's go with the absolute value of 6x plus 9 divided by 4 plus 2 is greater than or equal to 5. All right, so of course we've got to get that absolute value by itself first. What do you want to do? You want to add or subtract 2? We can times by 4, we can subtract 2. Okay, so let's subtract the 2. I'm okay with that. So that means we have this absolute value of 6x plus 9 divided by 4 is greater than or equal to 3. Now, yes, I agree. We can times both sides by 4. On this side, our 4's are going to cancel. So we just have the absolute value of 6x plus 9 is greater than or equal to 12. Good. All right. So now, but let's go back and look at that. So, but if you're going to times by 4, remember you got to times everything by 4. So you have to times this one by 4 and the 2 by 4. So then you'd have 20 minus 8. It's the same either way. Okay? That's fine. That's, again, everybody sees it differently. So now that the absolute value is by itself, we have to set up our 2 inequalities. Isaac, what's the first one? Good. Absolutely. I agree. There we go. Less than or equal to negative 12. I agree. You have to flip the sign when you make it negative. All right, so solving this one. I'm going to subtract 9 from both sides. I have 6x is greater than or equal to 3. Dividing both sides by 6, x is greater than or equal to what, Jess? One half. There we go. Good. I agree. I don't like how sloppy that is. All right. The second one, we're going to subtract 9 from both sides. So we have 6x is less than or equal to negative 21. Dividing both sides by 6, x is less than or equal to negative. 3 goes into both of those, so over 2. That I agree with. All right, on our number line, again, remember, see how these are in opposite sides, right? So really, 1/2 is going to be over here between 0 and 1, and that's a closed dot, and it's going to the, which way is it going? To the right. Good. The negative is over here, negative 7/2. That's also a closed dot, and this one's going to the left. So what kind of problem do we have here? Or, and if you look back when we got our absolute value by itself, it was greater than, which means or. Okay? All right, interval notation starts with the arrow of negative infinity, goes to negative 7/2 with a bracket, going to put a U in the middle, a bracket, 1/2 to infinity. All right, questions before we do one more. Last one, and I'm going to be done. Yes. Okay. Thank you, Libby. I agree. All right. How about something that looks like this? Make sure you put this example down. Something looks like this. Let's say I have -4 minus 6 times the absolute value of 3x plus 6 is greater than, whoops, not necessarily. Remember, you don't decide that till the absolute value is by itself, right? Okay, and let's say 20. Yeah, 20. Yes. No, because remember, what's this one doing? Yeah, so it's not like terms. This is the same, just kind of sidebar. If I had -4 minus 6x, because this is kind of our variable we're getting by itself, greater than 20. Can I add -4 and -6 together? No, right? So same thing here. This is what we're trying to get by itself, and that -6 is multiplying it. All right. Okay, that's what we were just talking about, Libby. We cannot combine those together. Stop. Okay, so the first thing we need to do, though, is we do need to add 4 to the other side. We're going to add 4 to the other side. So we have -6, the absolute value of 3x plus 6 is greater than 24. Now we want to divide by -6. Divide both sides by -6. I have the absolute value of 3x plus 6 is less than, right, because we're dividing by a negative, we have to flip the sign, is less than -4. Can an absolute value ever be less than a -4? So this one is no solution. No, the one on your worksheet is different than this. It's very close. No, I didn't even say that. Yeah, nope, it's the one actually on the worksheet is flipped the other way so you can actually solve it. I wanted to point out the reason I did this problem is because exactly what many of you started to do. You cannot combine these terms together. They are separate. One is adding and one is multiplying, right? Do we need another example showing that? Okay. All right. So you guys are not coming back with the exact same question tomorrow for me. Hold on. That's okay. Okay. So that's all right. On this one, once we got this absolute value by itself, an absolute value is always a positive number, right? Can that be less than -4? Can I get something in an absolute value that's smaller than -4? No, because it always has to be positive. So that's why this is no solution. Okay? Other questions? That's a good one. Thanks for asking that. All right, so again, on your homework, there's one that has a -4 minus 6 in front like that. Do not combine those together. Add 4, divide by -6. It is not. It's going to have a solution, okay? I'm telling you guys.